right, let's get into these two examples from lecture 26 finally. So we're going to start with number 45 here, where we want to find all the currents and voltages in polar form. So that means that we are going to want to go through and have the magnitude and the angle. And because of the way that this is set up, right, everything is in parallel, which means that the source voltage is going to be equal to the voltage across our capacitor, which is going to be the voltage across our resistor. So that's going to help us go through and find those voltages. And once we have those voltages, we're going to be able to go through and utilize Ohm's law. So for the total current, which we'll need to then go through and split between the capacitor and the resistor, we'll either need to use voltage divided by impedance, or we'll need to use voltage times whatever Y stands for. I can never remember. Once we have that for the parallel plate capacitor, we'll have V over XC or V BC, and for the resistor, let's just say standards Ohm's law, V over R or V times G. So this is going to be what we're going through and dealing with to go through and start figuring out what is happening. So there's like a couple different ways you can go through and approach this. So first thing that we're going to go through and do is we are going to calculate XC. So in order to go through and do that, we see that it is 90 ohms. That is something that is already explicitly given to us, and we know that it's going to lag 90 degrees. For the resistance here, if we want to write that in polar, it's 90 ohms at 0 degrees. But again, we're going to drop those ohm symbols just because we got enough weird stuff going on in here. So if we wanted to go through and start getting towards using our equations over here, what we are going to want to go through and do is our XC, we're going to want to turn into BC, which is going to be 1 over 90 at an angle of 0 minus negative 90. So that's going to go through, and we'll have 1 over 90 with an angle of 90 degrees. So it is going to lead for the resistor if we wanted to turn it into G, which don't really think is necessary, but it would be, oops, not 90. Sorry, this should be 86. Sorry, 68. And 0 minus 0 is still going to give us that 0 degrees. So that's going to go through, and now we kind of have this choice on what we want to go through and actually deal with. So we are technically done with the voltage part in polar. So we're just kind of ignoring that, and we'll just cover it again at the end. But because they're all in parallel, they all have the same voltage. They're all 10, 0 degrees. So it's really this current part here that we're focusing on, but we have all of these different voltages. So now we just need to decide, are we going to want to use Z, X, C, R, or do we want to use Y, B, C, G? If we want to go through and use Z, X, C, and R, we have those equations. We're able to go through and execute them. All we would need to go through and do is find Z, which for the parallel case is going to be R over XC, square root of resistance squared plus XC squared with an angle. That's going to be the inverse tangent of R over XC. So we have all of this information. We would be able to go through and deal with it. The only thing that's going to be a little bit weird is we are going to have to go through and deal with, right, squaring it in polar, turning it into rectangular, and then adding the two terms together, putting it back into polar, square rooting, polar, polar, we're good to go. Or what we can go through and do is we can say, well, hey, y is equal to the square root of g squared plus bc squared. And again, going through and dealing with it, we are going to have to kind of flip back and forth between them, and we'd have that inverse tangent of bc over g. Both methods completely go through and work out. Both of them are going to have that awkward, like, do we have to go through and convert things back and forth? And the answer is unfortunately yes, we will have to go through back and forth and convert it. For me personally, because I'm going to have to do the conversions anyway, it doesn't really make sense for me. I personally just don't really see the sense of going through and using y, b, c, g, but you can. It's 100% up to you though. So when I went through and did this, I did our z, which again was r, which is our 68 0 degrees, times xc, which is 90 minus 90 degrees, over the square root of those two terms squared and added together. And then with the angle part, the inverse tangent of r over xc. Oops. This would be a negative 90 there. So if we go through and do this, we're going to find that z is equal to 54.255 at an angle of negative 37.073 degrees. Now, if we had done this with y instead, we would have 1 over 54.55, which 255. So if we had done it with y, we would have gotten 0.01843 at an angle. It's the inverse of it, so I should have written this down. It would have gotten us 52.9269 degrees. Again, both methods technically go through and work out. It is whatever you're comfortable with doing. So now that we are ready to go through and find the currents, we'll just formally state that Vs is equal to Vc, which is equal to Vr, which is 10 volts with an angle of 0 degrees. That is one of the things we're looking for, and now we're just going to go through and use Ohm's law to go through and solve for our values. And again, it doesn't matter which version you're going through and using, you will get the same numerical value regardless of what it is. So if we go back, right, we're looking for the all current, so we want total, capacitor, and resistor portions. So for that total part, we'll have 10 at 0 degrees over our 54.255 at an angle of negative 37.073 degrees, which will get us 0.184 amps at an angle of 37.1 degrees. And that is our total current value. In case you wanted to see what that looks like, where if we did it with Vy, we would have 10 0 degrees, and then we'd have 0.01843 at an angle of 52.9269. Sorry, I messed that up on the other slide. We don't, I'll put a little note on it. It should be the 37.073. We need to get the same value. So multiplying that together, we get 1.84 amps, 37.1 degrees for IT. So both methods work out. It's just dependent on which one it is that you're going through and using. So whichever one you're comfortable with, go ahead and do that. So for IC, oops, we want to make sure that we're using the correct value. So here we have 90, negative 90, or the current through that branch, it's going to be 0.111 amps, positive 90 degrees. And then for the resistor, we have our 68, 0 degrees, or 0.147 amps at 0 degrees for IR. So you can, again, go through and use either. It's 100% up to you on which version you are more comfortable with using. But if you have any questions, please be sure to ask.